I'm just going to talk the whole time and not tape anything. We've got day 3 of PreCalc 4.1 notes today. And what we're looking at is revolutions. And we're going to talk about revolutions as in snowboarder type revolutions and how many times around. Now, we've done this already with angles, right? And everybody was happy with angles because angles are pretty and fun. And we all go, hey, 360, 720, 940, right? And 980, excuse me. And then when we're looking at this, the wheels of the bus fall off. So let's talk about what this means. In a circle, let's talk about it this way, see if I can get my circle around. Okay, we are going to be working with something called the unit circle. I've kind of alluded to it, I've talked about it, and what it really comes down to is, you saw it yesterday when we were talking about radians. We're talking about measures of radians. And yesterday we knew that there would be 3.14159 radians for a half circle, for 180 degrees. Well, we know 3.14159 as what? Really cool symbol. Yeah, it's really good with ice cream too, right? So when we're looking at this, we have pi. Now, we have gone pi. This is not only 0, but it's also 2 pi. Okay? Does that make sense? Because 2 pi is, that's pi, this is 2 pi. 2 pi is 1 revolution. Okay? Are you okay with that? Now, as we're thinking about revolutions and going around, 2 pi is 1 full go around. Well, when I look at this on this problem, I can't even get rid of it. It keeps coming back. Okay, when I look at this on this problem, if I can get this all grouped together so I can slide it all out of the way. Thank you for being so fast. Okay. I want you to keep in mind, it's just like we did the rotations with degrees. I mean, we did 360s and everybody was fine with that. Why can't we be fine with 2 pi's? So all we're going to do is divide by 2 pi. Okay, when I do that, what I'm doing is I'm finding how many total revolutions. And by the way, this one's going to be a monstrous donut. It's going to be one of those ones from Hans Bakery. You've seen the one, the glazed donut that's big as your head? Yeah? Okay, that's how big this donut's going to be when I'm talking about this. I'm going to draw this picture, and I got a big old donut. It's going around. Ooh, positive. Going around positive. Okay, but I've got to get my calculator too, or my cheat sheet of getting them done. So grab a calculator and put it in. Do you see what I'm talking about when I'm saying, hey, it's a really big donut? I'm just going to grab my cheat sheet here. So after you get that value, and whatever that value is going to be, I'm going to actually tell you. We switched the order, so my order and this is not the same order you guys have. We're looking at 10. Hey, look, I opened right to it. Cool. Well, when I look at this, that's not even the right one. There it is. Okay, so if I look at this, I'm looking at the fact that this goes around a bunch of times, but whatever my answer is, it's got a really big number, 0.5, right? Okay, well, let's talk about that. One time around, well, half time around's pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, 8 pi. Odd pi's over here. Odd pi's here, even pi's here. It's an integer. It's done right there. Does that make sense? So whatever my big number is, I take 2 pi times my 0.5, and that equals pi. That's my coterminal angle. Does that make sense? Yeah. This divided by 2. Because it's odd, I should get a 2 in there. When you did that with your calculator, little calculator stuff, if you do this, and this is why I abhor slant things. If you do this, this divides by 2, then multiplies by pi. So go back, hit second enter in your calculator, and place these parentheses in. Or just dump the pi completely, because you don't need it, because it's, you know, the pi was divided out. Do you see it? Okay, so be careful about that. That's like the bane of my existence as a math teacher, because everybody like assumes that the calculator knows that that's what your intention was, and it doesn't. So you have to have parentheses around those. And then who has the new version of the program where they have they don't no longer have the slant, but they have the horizontal? That's nice. You guys are spoiled. I'm telling you, that's really nice. But with that in mind, is everybody okay where I got my 0.5? Are we good? Now, we were asked here, for each of the following angles theta, find the coterminal angle. So this is theta coterminal, is pi to the given theta. Okay? And it's supposed to be between 0 and 2 pi, so that's it. Okay? And by the way, when I'm asking you to put my answer in radians, that's how I'm going to do it. Your range of your answers should be between 0 and 2 pi, because in degrees, this is actually 180 degrees. Okay? Now, then find the reference angle. It's actually a quadrantal angle, which means it's right on the axis. It's an axis angle. Beta is 0. There's no reference angle. It's 0. It's sitting right there on the axis, right? Are you okay with that? Yes or no? I've got some people okay with that. But remember, reference angle is the angle made with the x-axis and the terminal ray. Okay? And my terminal ray and the x-axis are one and the same. So it doesn't go anywhere. That's why it's 0. Now, keeping that information that we did in mind, and that was all I had to do, but I wanted to explain myself. They multiplied the pi out in this one. How do I do it? Remember, still the same way. Divide by 2 pi for those people with the slants. Get it done. Go ahead. Now, when you get there, your answer in your calculator should be 5752.259122. Now, a little caveat about your calculator. That was cool. Let's bring that back down because I can't reach that high. All right, little caveat about your calculator. It doesn't have ... after it, okay? But this number, as soon as I take that number away, and people are, how do you get rid of that? I subtract 5,752 from the number, and it returns 0.259122, and it gives me more digits. I just don't copy down the values there. I subtract the thing I don't want in it. I subtract the stuff on the left side of the decimal, and then it's whatever the percent is left. Now remember, it's a percent on 2 pi, full revolutions. So now, when I put that back in, I got, if I can get rid of this, there, so I have more room. I've got my 2 pi times whatever my calculator says, okay, for my 2 pi, and that returns my beta, my alpha in this case, 1.628. 1131. That's what's in my calculator right now. Can you get it in your calculator? I know you can write down what I've got, but I want to make sure that you understand how it was achieved. Are you okay that, first of all, because it's coterminal, I don't care that it went around 5,752 other times. I care what portion of the last time it's not making, okay, because I want to know where it's at. So right now it says 1.628, okay, which is a little more than 1.57. And people are like, geez, why is he worried about 1.57? Take pi and divide it by 2 in your calculator right now. Pi over 2 is 1.57 something, something, something. And people are like, oh, he's like a human calculator. No, it's an important piece of information. This is pi over 2. Okay, now think about it. What's half of 180? That's 90 degrees. What's half of pi? Pi over 2. Okay, radian-wise. So this is pi over 2. This is 2 pi over 2. Guess what? 3 pi over 2 And this is also 4 pi over 2, but you know, we know 4 pi over 2 as 2 pi, okay, as I'm counting in radians, if I'm thinking about that. So that's how I know that this angle is right about in here someplace. Okay, that's also how I know that I've got to get a reference angle to this angle. Okay, and my reference angle, my theta reference, I suppose they say find the reference angle beta. So I'm going to call it theta reference so we get used to the terminology, but they asked me to find beta. So beta is the same as theta reference in this case, okay, because theta was our original angle. Theta coterminal is this. This is theta coterminal, the coterminal angle with theta. The reference angle that is made, if I can get this in here, this is 1.628. Okay, I shouldn't even put that in there. But now I'm worried about this reference angle. Okay, I'm just going to subtract from pi 1.628. Dun, 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 whatever's in my calculator. That'll give me my reference angle, the positive angle in radians between the terminal angle and my x-axis. Does that make sense? Now, if you got questions, now would be the time to get after it. But oh, maybe I should just put that number in there. I got 1.513. Yep, no, not times, minus. Pi is 3.14159. I'm subtracting 1.628 from it to get 1.513. And just to make this kind of seem like it's a little bit different, let's talk about this for a second. Say this is, I don't know, how many, I'm making up something, okay? This is a made up thing, just to make sure you guys get what I'm doing. Say the coterminal angle is, or the angle we're working with. Let's just work with that because I'm worried about reference angle. The angle we're working with, let's make this 112, okay? What's the reference angle in degrees between 0 and 360, or better yet, 0 and 90 because it's a reference angle? That's this reference angle. What am I going to subtract it from? What? 180. So I'm going to go 180 minus 112, right? And that'll give me my 68. That's exactly what I did here. Does that make sense? Pi is my 180. That 1.628 is my coterminal angle, and I'm just finding my reference angle, and that's how I did it. Are you okay with that? I saw your faces, but does it make sense a little bit more? Okay, all right. Now, the reason why I'm doing it, and there's monstrous numbers, it didn't matter how many rotations I had. It was all about the fractional portion of the rotation, the percent of just one rotation that I'm concerned with when I'm talking about my coterminal angle, the angle that has the same end ray, right? Think second hand going around, that it stops in the same spot, okay? Now, the reason why I'm so concerned about that is I'm about to use the F word in class. We have fractional stuff, okay? But before I get there, let's bring back our friend. Okay? And right now, we have our friend, all right? And in this next problem, in problem C, what I'm doing here is I'm breaking it up into sevenths, and that freaks people out. So if I'm breaking something up in sevenths, how many sevenths is a whole, like one value? How many sevenths go into 1? 7, right? How many sevenths go into 2? 14. And people are like, well, what's the big deal about that? If I go a half revolution, that's 7 pi over 7. Are you okay with that? Because I got 7 sevenths to get there. If I go a full revolution, That's the same as 14 pi over 7. Are you okay with that? And why the 7? Because they picked it for me. Okay? Does that make sense? So there's a couple ways of approaching this, and the best way I felt as I was doing this is to explain it out this way this morning, because I was like, geez, I've got to be able to make this seem like it makes sense. Didn't I, on the other ones, divide by the full revolution? When I had degrees, I divided by 360. Okay? When I had the radians, I divided by 2 pi. Well, I want to divide by 2 pi here, don't I? I know there's a 7th there. But ultimately, I'm going to divide by 2 pi. Because whatever this is, I can put the 7 in there. It won't be as nice and neat. Okay, it'll be ugly with the 7 and the pi multiplied in. I've still got to divide by 2 pi for my full revolutions. Okay, but I'm going to do something really kind of freaky with fractions right now. So hang on to the bar for a second and play with me on this. What I'm asking you to do is recognize 2 pi in terms of 14 pi over 7. Isn't that still 2 pi? And according to rules of mathematics, I get to do this. Because a division by a fraction is the same as multiplication by that fraction's reciprocal. Are you okay with that? Trust me, there's going to be a shortcut coming soon, okay? What I want you to realize, the 7s will knock each other out. The pi's will knock each other out, okay? And my resulting value I'm going to deal with in my calculator okay? I am not done by no means. I'm just showing you the shortcut I'm going to do in the next one. What's 7 times 2? 14. I'm just going to go to this right away because it makes it faster. Okay, and I'm going to drop the pi. I don't care about the pi. And all this step, I want a different color. This whole step was just set up. This stuff was just set up to show you that if I double 7 and leave the pi away, I'm fine for a second. Okay, this is something to help me get my donut. And then I'm going to get the partial left, okay? So stay with me on this. Now that I've got this going on, go ahead and let's get that put in your calculator. I got to do this one too. So 46,365 into your calculator divided by 14. 46,365 into your calculator divided by 14. This is 3,311.785714. Okay? So that's what I've got in my calculator. I'm going to take away the 3,311. And now in my calculator right now, I'm going to do 14 times 0.785714. Now, I'm going to explain myself. When we divided by 360 and we had the fractional portion of a revolution, didn't we multiply by 360 to find how many degrees left from standard position where our angle was going to end? Okay? I'm doing the same thing here. It's just not 360. It's another version of measurement. Okay? So I'm going to multiply this by 14, and I should come up with 11. Okay? And this is 11. Okay? Can you tell I did it a few times today just to make sure we got this? Because I wanted to make sure it was clear, my explanation. Okay, now, that's 11. How many things did I break up the first half into? 7, right? This is 11/7 pi. 11 pi over 7 is my coterminal angle. Gosh, whiz bang. Okay, so this is my theta coterminal is 11 pi over 7. And I know it seems like, geez, you know, he did a lot of stuff up there. But remember, it's shortcuts for understanding revolutions, okay, in radians. So here's, are you okay with the fact that I divided by a full revolution, right? Just like we did with 360. And in doing so, we were able to see that when I have a fraction with pi in it, I can actually just double that bottom value, and that's a full revolution. Okay, so I'm dividing by a full revolution. Remember, this is a shortcut. It's not really true mathematics of what's going on. Well, in this case, it is what's happening with my revolutions. I dropped my 3,311. I'm worried about that fractional portion of a revolution, and I found out that it's 11/17. Okay, 11/17. Well, what's 11/17? Let me get this cleaned up so I can get this stuff out of here. So I have a clean slate with the 11/17 to clean that up. Remember, 11/17. This is not 17ths, 11/7. This is 7/7. Are you okay with that? 7 pi over 7. I need to go 4 pi over 7 more. So it's like right about here. This is my 11. I lied. Because 3, it's not going to be 4. 3, that's not negative, is it? I just got to double check. I was using it as negative. This is 3. This is about 4. So this is about 4 because I should have 3 more to finish. So this should be my 11 pi over 7. Right about there. Right? 11 pi over 7. Reference angle. What's a full revolution? 14 pi over 7. What's 14 minus 11? 3 pi over 7 is my reference angle. So over here I go, my theta reference is 3 pi over 7. Now, before we even go on to the next one, I want 2 things. First, I want you guys to try doing what we just did. I know I walked through it, okay, and I explained all the things I'm going to do, and I wrote it down as I did it, and I'm going to erase it and redo it, just so you can see how much faster it is once you kind of understand it. But if you do it a couple times before we do the next one's easier, I promise. So let's try it, okay? These are my 2 answers as I'm stepping through. So let's just erase what I did and look at it again for a second. How would I do this one? Okay, I get something in there, right? But I'm going to now work with my theta reference. My theta coterminal, actually. Excuse me. I want to make sure I have the right color. My theta coterminal is just going to be the information out of my calculator, and I'm going to pull that out. Hi, dear. Sure, certainly can. I'll forget these, of course, you know, if I don't put them back here. Now, did you get the 3,311.785714? Right? And so now I got my theta coterminal, and I know that was a full at 0.785714, ... That's going to be 11. Now, here's the thing. I'm finding my theta coterminal. I know that's going to be over 7. And it's going to be a pi in there. Because I took this out. Because the things I'm doing are a shortcut. Okay? So it's 11 pi over 7. Now, theta reference. I know that I have a full revolution, 14 pi over 7, minus 11 pi over 7 will give me my 3 pi over 7, and that's where that came from. All right? Most of this work was done in my calculator to talk about revolutions. All right? Do me a favor. It's your turn. Do this yourself, and then try that one. The only wrinkle with that one, it's negative. So everything you do, you got to flip around the other way. Okay? Give it a try. Okay? I know it's a drag. Some people are doing it and went positive, and you got to make sure you realize it's negative. And I know this idea in degrees isn't difficult. It's when we start working with radians because it's an alien foreign measurement that it seems they'll be really funky. Okay, but it's okay. It works out real nice. Now you're going to, no, not multiply, divide. And you're going to go by 22 pi because pi isn't in there. Okay. Okay, so, yep. Now, because 22, there are 22 elevenths all the way around. That's a full revolution. And what you have in there is a partial revolution. Multiply that by 22. Whatever it is, it's going to be, yeah. Your answer should be negative because you're going to go from standard and you go around clockwise to get there.
So the theta coterminal will be negative.
Theta coterminal is going to be negative, and then you can draw one that's, you can actually come up with a positive one 2 pi later, or since it's elevenths, no, is that one elevenths? Yeah. So since we're talking about elevenths, it's 22 pi over elevenths later, you know, that full revolution later. Does that make sense? Yeah. Okay. So let's try this, and I'm going to minimize this stuff because I went a little crazy to make sure everybody can see what I was doing. And we will bring up my little cheat circle. Bring up my pi there. Now, in this one, I got the pi there. I got a negative, so I'm going to have to remind myself that's what's going on. Okay, but remember, I'm just dividing that by 22 because the pi was there. Now, keep in mind, the pi was there. Okay, so I'm in my head, I'm taking 22 pi over 11. I'm dividing the whole thing. And in doing that, I have this come out because I'm really dividing by, and that's my result, okay, so far. That's what I'm doing, so I have it mathematically, you know, I'm taking 2 full revolutions and putting it, that divides out to be here. And at this point, I should have my 0.7857, excuse me, I lied, my 0.59. I'm going to take that out, so now if I'm talking about my theta coterminal, let me get that up so I'm not in the way with people behind me. Get rid of that. I got my theta coterminal, which is going to be negative, by the way. I've got 22 times 0.5909 in my calculator. Are you okay with that? Did you get that so far? And then after, say that again? This 0.590, in my calculator I went 789637 divided by 22. I dropped the stuff on the left side of the decimal because I'm only concerned with the fractional portion of a revolution. Okay, then I multiply that by 22 because I find out how much of a revolution I am in radians. Okay, and that's going to come out as 9, but it's negative 9, negative 13 pi. It's going to come out as 13. Negative 13 pi over 11 is what my solution should be. Yes or no? You're doing okay. I have some that are like, okay, and I have some that are staring at it and aren't happy with it. They have that mean look at the board. It didn't do anything wrong, folks. Okay, it feels really bad some days. Are there questions, clarification questions? Are you okay with where I got these numbers? And why it's 22? Because it's a full revolution. Are you okay that I'm at negative 13 pi over 11? Now, keep in mind, this is a negative coterminal angle. How would I get it to be positive? Adding 22 pi over 11 to it. Does that make sense? Because that's a positive coterminal of 9 pi over 11. Are you okay with that? And some people right now are like, Bloom, why did you do that? Look at the directions up top. It says I have to have it between 0 and 2 pi. Okay, so my theta coterminal positive is there. My reference angle at theta coterminal, and let's talk about that looks like. 9 pi over 11 is like right here. Okay, 9/11ths of pi. It's not quite a full pie, right? It's like someone's been around eating my pie. It was you, wasn't it? No. So I've got 2/11ths pi left. That's my positive angle with my terminal ray in my axis. My theta reference. 2 pi over 11. Are you okay with the way I'm stepping through it? I know it feels like it's really long when you first see these. I did not want to blow you away by just, well, you just do this and then we move on. Okay? Because it's important for me that you guys get these. Any other follow-ups with this one? Now, notice how hard it is to do when we're in radians because it's not degrees. It's tough because we haven't used it before. Be patient with it. If you need to, help yourself. On the assignments, when we first start doing this, switch it to degree, go, okay, in your mind, it'll make sense. And then switch it back to radian. Do not do that on the test because you will have rounding error all over the place. Okay, work in radian, be in radian. I just suggested that at first as you're learning it so you could visually feel better about your answer. Okay, so make sure that that is known because I've had people always switching back and forth and they're wasting a lot of time and then they're doing tons of rounding error issues and their answer's wrong. Okay, now in this next one, in applications it is sometimes necessary to connect angular speed. Okay, measured in units like revolutions per minute to linear speed, measured in units like miles per hour. Now, this means we need to connect the two by one of the arc length formulas or by using conversion factors that equate 1 radian of angular measure to 1 radius of arc length. Okay, now we talked about some stuff about this with arc length, angular speed, and everything, but what I want you to recognize is this. I'm just used to using stoichiometry. It's that conversion factor stuff, okay, that you guys did in physical science. Okay, so once I start it, maybe you'll get it. But the first thing I need to do on this problem is read properly the problem so we all are on the same page, right? Okay, Albert Juarez's, I think it's Juarez's, if someone is better, please help me with my pronunciation. Truck has wheels 36 inches in diameter. So I've got a wheel moving along that's got a diameter of 36. That means I got a radius of 18. Y'all okay with that so far? Okay. Now, if the wheel is rotating at 630 RPMs, revolutions per minute, find the truck's speed in miles per hour. Okay. Now, here's the thing. This revolutions per minute is kind of a big deal, but I want to know how far of a distance my tire goes around in 1 revolution. That's circumference. We learned it yesterday. You know, we were talking about it yesterday as S equals R theta. Okay. Now, we know theta to be 2 pi, right? In radians. And people are like, why is he using 2 pi instead of degrees? I have my reasons. But remember, I've got 18 times 2 pi. I got 36 pi inches. Okay, that's my circumference. Now, let's visit circumference for a second. Because you all knew circumference was, well, circumference is 2 pi r, Bloom. What's your issue? Radius times revolution. No way. We've been doing this the whole time using radians and I didn't know it? Yeah, you have. Okay, so keep that in mind. So it's not that alien. Now, here's the deal. We have 36 pi inches. And by the way, the reason why I'm not multiplying it out, I will start having rounding error. And this carries my value all the way through. So I'm going to multiply at the end. But this is in inches. Okay? Now, and that's 1 rev. And I know that my car is going to go revolutions per minute. Right? That's RPM, revs per minute. I want to know miles per hour. I have 2 things I have to deal with. I've got to get from inches to miles. Okay, inches to miles. So I've got inches. There are 12 inches in 1 foot. Now, when I'm doing my conversion factor, how do I know which one's which? I want to get rid of inches as a unit, and I want to make sure that I'm doing it correctly. I got revs gone, and right now with that, I've got inches gone. Well, that's cool. I got it in feet, but I need it in miles. Oh, they're 5,280 feet in a mile. 5,280 feet in 1 mile. Okay, feet and feet. So now I'm in miles per minute. Okay, measuring the flash, see how fast he goes. Okay, miles per minute. Right now, though, I got to go from minutes to hours. And minutes is on the bottom, and I need hours on the bottom. So 60 minutes in 1 hour allows me to get my answer in miles per hour. And now it's fat fingeritis avoidance time. Fat fingeritis, by the way, to those people who have never had me as an instructor, is the fact that your fingers are much bigger than your calculator. Not that you have gained any weight in your fingers, or maybe you need to do some exercises. Okay, let your fingers do the walking. Okay, but make sure you know that you might push 2 or 3 buttons at the same time if you rush. So try to avoid them by everything on top should be multiplied, and then everything on the bottom should be multiplied to try to achieve 67.473 miles per hour. That's what we're shooting for. Gosh, I hope so, because otherwise I've really screwed up. We doing okay? Yes, no, maybe. It came out? No way. Ta-da! Hey, and now for my next trick. Okay. You okay with 67.473? You okay with why I chose the conversion factors I did and oriented in the way I did to get rid of my units? We're good? Okay. So, kind of doing the next thing, because these 2 examples we're supposed to do here is all about going 1 radius, 1 radian, seeing what's going on. It's about us working with radians, and that's why I did this way versus pulling out my other one using degrees and saying it was 360 degrees. Now, nautical miles. Not sure if you know, a nautical mile is the length of 1 minute of arc along the Earth's equator. 1 minute of arc, okay, as it rotates. Now, the central angle, AOB here, this central angle of Earth measures 1/60th of a degree. It intercepts an arc that's 1 nautical mile long. Now, the connection between a nautical mile and a regular mile or a statute mile, when I talk about, hey, I live 5 miles from school, 6 miles from school, that's a statute mile, okay? That's a mile that's in the 5,280 foot mile, okay? Now, although Earth is not perfectly sphere, its diameter is on an average 7,912.18 statute miles. A nautical mile is 1 minute of Earth's circumference, okay? Where am I going here, kid? Oh, that's my teen. Oh, thanks for doing that, because I forgot to tell you. I had a word problem. I should have a word answer. I apologize for that. I got so excited about nautical miles. Hey, don't worry. I'm not going to derive them. I thought about that just for you. We're just going to use the conversion factor. I know, it's down and dirty, but that's what we're going to do today. Bless you. Okay, now, when we're looking at this, keep in mind the arc length formula allows us to convert between nautical miles and statute miles, which is land miles, 5,280 feet. Probably would have been a good thing for people to remember at the previous one, the 5,280 feet in a mile. But, I kind of talked about that a few times. The conversion factor, I'm not going to make you derive it. Okay, we're just going to use it. And people are like, dude, this is it? Yeah, all I'm going to do. Megan McCarty pilot for Western Airlines, frequently pilots flights from Boston to San Francisco. From Boston to San Fran, it's 2,698 stat miles. Remember, that's the miles we're used to. Every one of those miles is 5,280 feet. Well, if I have a stat mile and a nautical mile, and she wants to know how many nautical miles is it? I have a conversion factor. You ready? I want to get rid of stat mile. Go! That's it. Just a little stoichiometry, very small compared to the last one we did. Yeah, no, I don't know that. And that's the 20-second ticker on that. And people are going, boom, what about problem 6? Problem 6, I love to death. We'll do tomorrow. Because tomorrow, this is what we've got. I really got problem 6's notes. And work time in class. It'll be cool. Okay? Maybe a little bit more talk about the unit circle and measurements. Okay? With the stuff that we've got. I had some folks asking questions about their worksheet. May I steal this? And the questions on the back side, it says, draw the angle theta in standard position. And that's 15 through 20, you know, on the very bottom of the second page. And y'all got, y'all got this going on. And they're asking about standard position stuff. So in 15, you got pi over 6. By the way, that's 30 degrees. In 16, you got pi over 3. That's 60 degrees. And you got 17, you got negative 3 pi over 4. Okay? You okay with this so far? Now, here's the deal. In my unit circle, 30 degrees is right out here. This is pi over 6. Okay? Actually, 30 degrees is over here. This is 5 pi over 6. This is pi over 3. This is about 2 pi over 3. This you already know is pi over 2. This is pi. This is 0, also 2 pi. I'm not going to worry about those yet. Okay? When we're looking at this, have I used all the colors? Gosh darn it, I need more colors. Okay. So we're looking at this. Oop, pi over 4. I know I'm slow. 3 pi over 4. Now, those are the values, the only values we work on in the unit circle. Pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, 3 pi over 4, 5 pi over 6, and pi. And then repeat, 7 pi over 6. Remember, this is 4 pi over 4, 5 pi over 4. 6 pi over 4, which is 3 pi over 2. 7 pi over 4 as we go around. But when we're talking about pi over 6, this is pi over 6. If I'm talking about this, it's right there, pi over 6. If I'm talking about pi over 3, talking about that right there. If I'm talking about negative 3 pi over 4, remember 3/4 of a pi. It's not, by the way, this, because that's more than 3/4. 3 pi over 4. Now this is 3 pi over 2, negative 3 pi over 2. But 3 pi over 4, 1, 2, 3/4 of a pi. This is negative 3 pi over 4 down there because it's the negative. Okay, when I'm looking it over. Does it make sense? Kind of. Based on the things that we did today, I know it's like, whew, that seems like a lot. We're going to do more stuff with the counting pi over 4s. If you don't have that understood and you need more time with it, please hang on to this. We will talk about this in its entirety tomorrow, right after we do the example 6 problem. Then we will go on and have work time with the next stuff, but it shouldn't get in the way with the stuff you guys are able to do from 4-1 day 3. Okay? Thanks for your time today, guys.